Lecture number 25 contains partial fractions, and then we will solve the sums related to partial fractions. Before going towards the discussion about partial fraction, we will first discuss what is fraction, what is rational fraction, and then we will discuss the definitions of proper fractions and improper fractions. So first we will go towards the definition of fraction. What is fraction? The quotient of two numbers or algebraic expressions is called a fraction. Quotient of two numbers, you have definitely done it in the junior classes. How to find out the quotient of two numbers when we have to divide the two numbers. So the quotient of two numbers or algebraic expressions is called a fraction. The quotient is indicated by a bar. We know that the identification of a fraction is the bar. We write the dividend above the bar and the divisor below the bar. We know that we write the dividend above the bar and the divisor below the bar. For example, x square plus 2 by x minus 2 is a fraction with x minus 2 is not equal to 0. Since you know that the denominator cannot be equal to 0, if it is equal to 0, it results in an undefined number. So the restriction is often made for the denominators of a fraction for not to be 0. So the denominator of a fraction is not 0. Here the denominator is x minus 2. So in this example the condition or the restriction is made for x minus 2, that is x minus 2 should not be equal to 0. Now coming towards the rational fraction. What is the rational fraction? We will discuss it. An expression of the form nx by dx, where nx is actually representing numerator which is having a polynomial containing x, and d of x means a denominator containing polynomial of x with real coefficients, and denominator of x should not be equal to 0. We know that the denominator shouldn't be equal to 0. So such expression of the form nx by dx means that if two polynomials are written in the form of fraction, then as a whole we consider it as a rational expression. For example, x square plus 3 by x plus 1 whole square into x plus 2 and 2x by x minus 1 into x plus 2 are rational fractions. So these are the rational fractions. Why? Because in the numerator we have a polynomial of x, and in the denominator we also have some polynomial of x. So it is of the form nx by dx. So it is called a rational fraction. Next is proper fraction. Now what is proper fraction and what is improper fraction? Proper and improper fractions are actually the types of a rational fraction, in which if a rational fraction is having polynomial in the numerator with lower degree than that of polynomial in the denominator, then the fraction is considered as proper fraction. So simply, if the degree of the polynomial in the numerator is less than that of the degree of the polynomial in the denominator, then we consider a fraction as a proper fraction. Its opposite is the improper fraction. That is, first we discussed that if the numerator's degree is less than that of the denominator's degree, then the fraction is called the proper one. But if the degree of the polynomial in the numerator has greater degree than that of the polynomial in the denominator, then we consider it as an improper fraction. So a rational fraction nx by dx is called an improper fraction if the degree of the polynomial nx, that is whatever polynomial is in the numerator, but if it is having greater or equal degree to that of polynomial in the denominator, then we consider it as an improper fraction. Examples are given as 5x by x plus 2. Here 5x is having a degree as equal to 1, whereas in the denominator we have x plus 2. The degree of the polynomial in the denominator is also 1. So here they are equal, and we studied the definition for both equal and greater. If the degree of numerator is equal or greater than that of the degree of denominator, then the fraction is called an improper fraction. In the second example, you can easily observe that in the numerator we have 3x square, that is the degree of the numerator is 2, while that of degree of the denominator is also 2. Here the two degrees are equal, so that is why the fraction is an improper one. Just look at the third example. Here in the numerator we have 6x4, and in the denominator we have x cube plus 1. Here the degree of numerator is 4 and that of denominator is 3. Obviously the degree of numerator is greater than that of the degree of denominator, so that is why the fraction is an improper one. Now what is partial fraction? The resolution of a fraction into its components is called partial fraction decomposition, and the components in which the fraction is decomposed are called partial fractions. For example, if we add 2 by x minus 2 plus 3 by x plus 1, the resultant fraction is this one, that is 5x minus 4 by x square minus x minus 2. This is how you will have to add the two fractions to get their resultant or get their sum in the form of a fraction. It is 5x minus 4 by x square minus x minus 2. But what will we have to do if we have to find out which two fractions are added to get 5x minus 4 by x square minus x minus 2? So for this we have a method or a process which is called partial fraction decomposition, in which a simple fraction is resolved into its components or in its parts. As you can see in the figure, that 5x minus 4 by x square minus x minus 2 is resolved into 2 by x minus 2 plus 3 by x plus 1. This method is called partial fraction decomposition, and the parts in which it is decomposed are considered as partial fractions. So if we have to resolve a fraction into its components or parts, we do partial fraction decomposition, and the components or parts are called partial fractions as shown in the above figure. Now we will have to do the related sums. For this we will have to first resolve the algebraic fractions into its partial fractions, when the denominator of this particular fraction should consist of non-repeated linear factors. What is meant by non-repeated linear factors? As you know that the factor is considered to be linear if the degree of it is 1 and not greater than 1. So here the factors which are involved in the denominator should have the degree 1. 7x minus 9 by x plus 1. You can easily observe that x plus 1 is the linear factor since its degree is 1. Similarly, x minus 3 is the linear factor since its degree is 1, not greater than 1. Now first thing which you will have to check is the linear factors. The denominator contains the linear factors, but they are also non-repeated. Since we do not have x plus 1 whole square or x minus 3 whole cube, so it means that x plus 1 is only for once. It is not being repeated. So since it's x plus 1 whole power 1, which shows that x plus 1 is only for 1, so it is non-repeated linear factor. Similar is for x minus 3. It is just for 1. We have not been given x minus 3 whole square or x minus 3 whole cube, which means that it is non-repeated linear factor. So how are we going to resolve them into its partial fractions? First of all, we write that let 7x minus 9 by x plus 1 into x minus 3. One thing which you will have to check before solving it is that either the given fraction is the proper one or improper one. Obviously the given fraction is the proper one, since the degree of the numerator is 1 while that of the degree in the denominator is 2. Since we have the two factors being multiplied to each other, so its degree is 2. Here the degree of numerator is less than the degree of denominator, so the given fraction is the proper one. If the given fraction is the proper one, we just start solving it, or we just start decomposing it into its partial fractions. But if the fraction is not the proper one, if it is improper, then we will have to first resolve it into its proper fractions, then we will have to resolve it into the partial fractions. So since the given fraction is the proper one, so we will have to just start resolving it into its partial fractions. For this, let 7x minus 9 by x plus 1 into x minus 3 is equal to a by x plus 1 plus b by x minus 3. It's our equation number 1. First thing which you are going to do is to write the fractions separately. But since we do not know about the numerators, what should be the numerators, and we are going to find out the numerators. The denominators are with us. We know that one fraction may have the denominator as x plus 1 and the second may have a denominator as x minus 3. But we do not know which two terms are added together or subtracted together to get this 7x minus 9. So we are going to find out the numerators actually. For this, what are we going to do? We will have to multiply both sides by the LCM of the denominator. The denominators contain x plus 1 and x minus 3, so the LCM is x plus 1 and x minus 3. After multiplying both sides by x plus 1 and x minus 3, we just get 7x minus 9 is equal to a into x minus 3 plus b into x plus 1. Now since the denominators contained the linear factor, so we can apply a zeros method over it. Now what is the zero method? First we take the first denominator. Here the first denominator is x plus 1. First we take it as equal to 0. After taking it as equal to 0, we get the value of x as minus 1. Now what are we going to do with this minus 1? We are going to put this minus 1 in place of x in equation number 2. So we put x is equal to minus 1 in equation number 2 to get 7 into minus 1 minus 9 is equal to a into minus 1 minus 3 plus b into minus 1 plus 1. This is the reason why we apply zeros method, since by using zero method, one out of the two unknowns are temporarily eliminated, so we may easily find out the value of one unknown which is left over there. Minus 7 minus 9 is equal to a into minus 4 minus 16 is equal to minus 4a. Dividing both sides by minus 4, we get a is equal to 4. Similarly we do it for the second factor, that is x minus 3 as well. Putting in equation number 2, we get 7 into 3 minus 9 is equal to a into 3 minus 3 plus b into 3 plus 1. Again here a will be eliminated and we will get the value of b very easily. So this is why we apply zeros method. But keep this thing in your mind, that zeros method are only applied to the linear factors. Now the last thing which we are going to do is putting the values of a, b, c in the original equation, that is we are going to put the values of a and b in this equation, that is equation number 1. So we get 7x minus 9 by x plus 1 into x minus 3 is equal to 4 by x plus 1 plus 3 by x minus 3. So this is how we resolve a fraction into its partial fractions.